Hi everybody, I hope you're keeping well. I just was playing around with a bit of my thermal tuning software, the FLIR tool stuff that I use, and I thought I'd do a video, mainly because I don't think I've done a demonstration of tuning, or what you can do with it. So, I don't know. This is FLIR tools. It's there's a paid version, but this is the free version that you can get. You can do some basic tuning with it. You can also create some reporting to a degree with it, but I don't use it for that. I just tune the image and then I take the image out and I put it into my own report. But we can import images, add images. We have a library. There is a reporting function, as I say, where you can drop images and photos and do stuff and annotations, and you can change your branding. But I don't go anywhere near any of that thing. So let's look at an image. So we've got 2021 images. We've got 2020 images here, May and June. We can just click a day. We go to there's a load of images here I took last year, and we'll just work on one of these here that I want to take in, have a play with, and we'll go with this one. So I've opened it up, and there's information in the top right here, and this is actually, this is very important. It gives us an understanding of the resolution. Now, one of the benefits of the FLIR software with the camera that I use is you have the ability to enhance the image. There's the single version here of the image, which is a 468 by 348 resolution straight from the imager itself. But then there's this option here of the enhancement using something called the Ultramax, and what that does, if I open this original image from the camera, you'll see that there's a circle here, the spot or the spot meter on the image. Because the resolution is actually a smaller image, the spot is bigger. And so if I move this around, I have many more pixels. It's much harder to get an accurate value of temperature with such a large spot. Okay, and so here's my spot 1, which is this point here. This is the measurement there of 26 degrees. This is limited by my resolution. Okay, so look at the size of that spot. It's about the size of that circle there. Just that's a screw there. Okay, the spot is about the size of that, isn't it? Okay, so let me just exit this and open up the enhanced one, which is this one here. High resolution, and you can tell by the smaller spot size. Okay, so high resolution, and the spot is significantly smaller. Okay, it just means that I can actually have, because there's more pixels in that one spot, so I can actually get better accuracy here. But I don't really want to use the spot, so I'll just delete that. What's on the screen now for me? Well, up here I've got the thermal image, and I've got here the real-time image. Fairly evident all that is. I could use that for reference if I want to, but I'm just going to stick with this. I took this image because clearly that you can see the 3 phases here. Okay, L1, L2, L3. You see that there is more loading on L1. And I found that, that's okay. That a balancing might be worth reporting, because actually the collection of a brighter light here, or a warmer temperature to the bottom half of the fuse, I was actually really intrigued with this, and I wanted to find a way to show that. And if you kind of like just gradually glare, you see that there's this kind of circle of light kind of coming out of this spot here. Yeah, I can play with the tools here, and I'll go through those tools in a moment to just see if I can find a way to better illustrate this, so that I can make my observation clearer for the client. Up in the top right, I've got the file name, date, where it's taken. Everything is like timestamps and everything, which is great. I've got the emissivity and the reflective temperature, which was set on the camera. I can change that. I can change the emissivity to 0.85, for example, and that will then change all of the measurements within the image, and there's some adjustment. Okay, I can change it to 0.5. Yeah, all the images and the numbers will be changing accordingly. to it. But I don't want to do. I don't want to do any of this because I've made all the changes on the camera already. But if you take the image and then you adjust the emissivity later, that's not a problem as long as the image is correctly collected. So I covered this in the webinar that I did where I talked about having the right resolution, the right scale, focus, okay, and distance. You can't change any of that stuff once the image is taken. But if you get all that stuff right, you can then change other things later on. Okay, so I'll keep it at 0.95. The reflective apparent temperature I'm going to keep at 20 because there's no other real targets reflecting from this, so it's fairly standard, that one. Okay, camera model, the serial number, the lens, okay, the resolution of the image, the file size, the date created, last modified. That's fairly standard information there. I've got the span down the right here, so I can see you've got here the 27.8. This is the representation of the whitest light in the image that's there. Okay, so that's the highest temperature in the image, really. Okay, to a point, and the lowest is 18.5. Now let's say that there's a lot of sky in the image, or there's lots of there's lots of dark space I just don't want. I can bring the baseline of the image up to an area that better represents the narrower area that I want to measure from, but that will make a lot of the image black. So let's say, for example, I was only interested in temperatures from 25 degrees. Okay, I could change that to 25. Okay, now everything in this image now is a representation of anything that's 25 degrees or above. Okay, it's a bit more of a contrast on the fuse. You can see clearly here the heating and that it's kind of cooling down across the top there. But really, giving that to the client is just going to be a bit crap. So I will choose to go back to auto and play around and see what else I can do. Do I want to take any measurements? Well, I can. I mean, we've just looked at the spot. Here's the spot tool up here. Click that. I can add a spot. Now it appears over there, spot 1, 27.9. I can move that around. And wherever I rest it, it will then just display the image. I could have another spot. I just click one, add another there. And then I can move that up to here. I can move that down to here. And I can then say, what's the temperature difference between those two? So I could go, well, I can just work that out. Or I could add a delta. I could add the delta. Go to the setting of the delta. There's a delta here. Now I've just clicked this here, added a delta. And if I click the setting, I can go right. I want spot 1 and I want spot 2. Okay, I want the difference between the two, and that is 0.9. Fairly simple. Okay, and this obviously will go on to the report when you do reporting. Okay, you can save the image and hit the report tool, and that information will go there if you want to. But I don't like that, so I'm going to get rid of that. I might use a line profile instead. Now, a line profile, you can drag along a space. So, dragging it all the way up here, and then releasing that, it will then have the line, then on the line will be the pixel that's got the highest temperature and the lowest. I can see that here again. I've got maximum, I've got minimum, I've got average. If I wanted an average temperature for space, I don't want average. So if I go to this marker and I right click and I do the parameters, I can go, okay, let's not have the average. I don't need the length either, but I could have length if I wanted to. I'll okay that. So that's now gone, but I still want the line profile delta. I'll add the delta. And then I come here, it's given me reference temperature minus the line maximum. I don't want that. I'll adjust it to line 1, and it's maximum to minimum. I line that, and you can see now the line profile has a 2.1 degree fall along that. So that's a better representation, because I can now say, right, okay, there's a good 2 degrees of change in temperature just along there. There's a 2 degree shift, suggesting it's a lot warmer at one end than the other. Okay, so that's a nice way to show the data and to get the numbers. The other options I had was I could do this box. And in the box, I could drag the box over the fuse, and then it will highlight in that area the lowest and the hottest. But that lowest is outside of the fuse, so that's not going to work. So I can adjust the box to be kind of the shape of the fuse holder, like this. But this really is just faffing around now. Okay, and yeah, I've got a bit of a hot spot there and there, and I can now go to the box here, maximum 28, minimum 24. I can then click the box. I can go to the parameters and I can remove the average again, and I can then add another delta just for the box. So we'll add this delta here, and we'll go okay, box 1 and box 1, and we'll go again maximum to minimum, and we'll go right, what's the delta there? And you can see here there's a 4.3. That's a significant difference between my line profile. Okay, but this is where you need to understand a bit about the geometry, about the way the heat is coming out of the fuse. So there's heat coming out of this way, but there's also heat coming out the side. And that's a significant difference. Okay, but the clear thing is there is still a warmer end here than there is at this end. So I can choose whichever one I want. To be honest, the line profile is enough for me. But if I wanted to be dramatic with the numbers, I could use this box because it gives me the larger delta, and the delta is a change, it's a temperature change from one point to the other. So I can use whichever one I prefer. Let me just tidy this up a little bit. Get rid of that. Get rid of that. What's the other ones I've got here? I've got this ellipse. It's not really helpful for me, this one. You know, I could maybe try to fit it in, you know, but really it's a case of, well, I'm missing all of this and all of this. It's a case of what's the point? Okay. I've got the delta there function. Okay. I've got here rotating the image and the measurements around. I don't want to do that. That's just a bit of a faff, really. I've got this one. This button here is set auto adjustment region. So I could click this, and what I could then do is I could just try to highlight the area that I really want my scale and my span to focus on. And if I do that around here, you'll watch it automatically adjust. Okay. So it's just got rid of a lot of the low end that it doesn't really need to worry about. And you can see it's brought the bottom up to 20. Okay, I could tighten that up. I could bring it in. You see, it's a case of whichever. The only reason there's a lot of this still here is because I'm allowing this cold space. If I bring this over, it's going to focus a lot more on the warmer bits because there's less of the cold space in the box. So I can move this around and think, okay, well, that's doing a lot of automatic adjustment for me. It's definitely making that look more dramatic, but is that the image that I want to give at the end? Probably not. So I'll probably take that off. Go back to auto here. There you go. So what can I do? Well, what other options have we got up here? Okay, up here there's this. This is what we've got. This is the thermal image, which is this. This is the thermal fusion. Okay, thermal fusion is a weird kind of blend of the thermal image over the real-time image, and the fusion is adjusted by these sliders. You can see here there's information. I don't know if you can see, there's information of the real-time image here that's at the low end off of the thermal gradient. If I wanted to include it, I would then drag it over it, and now you can see it's going over all of the real-time image to a point where I've no longer really got the real-time image, which kind of makes it a little redundant. But you'll notice that the fuse is still here. And the reason the fuse is here is because that's actually above the limit. I have to push it up this way to cover it. So this is thermal fusion, where you can try to add a bit of real-time image into the other image. It's a fairly useful tool, but it's actually kind of what I did use for this. So what I did is I lowered the real-time image just to highlight the fuse itself. So a bit like this, and then I brought down the top end just to add a bit more there. Okay, that could work. It's a bit bright and it's a bit ugly. So I could go, no, don't like that. So I can then just go to auto, go back to thermal. I'm back where I was. I've got here this thermal MSX. Now, thermal MSX is used with all of the FLIR's cameras, and it's just a way that merges some of the technical information of the real-time image underlaid onto the thermal. But you do need to remember that the real-time image and the thermal image are two lenses, and there is a bit of a gap. So depending on your angle and your distance, the MSX and the real-time image may actually be significantly out of alignment. And something that we don't really have here is a way to bring that back. So if I click it here, you can see now the fuse is there. So it's a good representation of the fuses. A lot of people do like using MSX. And I get that. And I will use it on panel boards where I would really like to see the words and the information underneath the image like this. The only thing is with me personally is it takes away a lot of the smoothness of the thermal image, which really, when you pay for a higher end camera, is what you're getting, is the smoothness in the image and the pixels. And so when I put the MSX in, I kind of feel that it looks like a cheaper camera, so I don't really like to use that. But that's just because I'm an absolute snob. I prefer the smooth thermal image over that. But you can see there's a lot more information here, and if it gets the information to the client, then it's the better approach. What else do we have up here? Well, we have the thermal, we have the thermal fusion. We've then got the real-time image. That makes sense. And we have this one, thermal blending. Now, thermal blending is a bit like thermal fusion, but you can see it's a lot more subtle. It's not so much some of the image being thermal, some of the image being real. It's trying to overlap them together. So now, if I was to try to bring this down and bring this up, just to get to the area that I want, which is the fuse, I can chase that heating area just to that fuse. Now that's gone white, so let's lift that up a bit. Okay, let's lift up a bit more, because if the more I lift up the top end, the more yellow is going to be in that image. Okay, because the top end is white, and if I lower the top end, the whole thing becomes white because I'm lowering the top here. If I raise the top end, you'll see this number this number here at the top of the span is going to climb as I slide this along, because I'm lifting the top. And as I do that, watch the fuse, and you'll see it fills with yellow, which I think actually looks nicer than just having it bright white, because if it's bright white, there's no information. Okay, I can actually push that. I'll push it to 35. So I've got just a lot of nice color in this image. Now what I'll do is I've got a lot of this color here, which is coming from around the bottom of the fuse, and I've got this color along the cable. So I'm just going to manually lift the bottom end. This lifting here, if I drag this to the right, look at the number here, this goes up. So I'm lifting the bottom. Okay, and when I do that, lifting the bottom, what I'm doing is I'm chasing in all the darker color, which is the cooler temperature. So I want to lift the bottom here, just to chase this color down the cable a little bit, just so that this is really where all the drama is happening. So you'll see it's just retreating back to the fuse. About there, it's pretty much going to show me all the information I need in this image. The key thing is the thermal image is still there. There's the span of the actual detector. I can bring the top end down if I want. I can put the line profile back in if I want it, or I can just have the information and I can have the thermal image for a bit of a dramatic effect. It depends on what's best for the client. Okay, so I can have the thermal line to give the information. I could just leave the image like this. I could put a spot in, but you know, you'd want to have another spot up here to see the blend. Okay, I personally, I think when I did this, I left it like this. I put the thermal line in like this. I put the delta in like so. And I think I got rid of the average because the average is not needed. And I think I pretty much submitted it like that. I think. Because it's got here, obviously that's a 1.6 degree, so I can just add a bit more information by going, moving this along. There you go, there's your 2 degrees. So there's a 2 degree shift from there to the top of the fuse holder there. And just so you know, this actual picture was done this way to the client, and it was recommended that this be looked at the next opportune moment, and it was put into the report that it needs to be looked at. And a couple months after my report was done, they went to this due to some other means, and they took the fuse holder down, and it had basically all burnt out. Yeah, so that was evident from this, and the loading was, the loading wasn't that much here, but it was raised on the thermal report to inspect that, and they did get to it, and it had burnt out, and it needed to be replaced. So it was a pretty successful find. And before I finish this video, let me just show a couple of other little things. So let's go back to the start. That wasn't the start, was it? It will be if I do this and I do this. Back to the beginning. What's the other button we've got here? So that's the one I chose. I chose the blending, and I kind of shrunk into it. But there's this other one here. So with the blend, you've got this slider, and this slider just tells you how much of the blend is going to be thermal, how much of the blend is going to be real, and you just find the right point. This other one here is picture in picture. So I could say, okay, let's grab that, let's push this over the fuse like that, and let's then just slightly move that there. Yeah, and I can do some adjustments with the span on that. I can go 35, and I can lift the top to 25, make it a bit dramatic like that. Yeah, again, with electrical panels and stuff, sometimes the biggest challenge is actually showing the client where a particular device is, especially if you've got lots of MCBs. So something like this, which is over the real picture, may work for you. Yeah, with the fuse, for me, the image I submitted was pretty much adequate, but you could do that. Okay, if you don't want the black, so much black, then you bring the bottom end back down to maybe, I don't know, 15. Yeah, but you can see that you're going to start just having a more of a blend of colour. Sometimes it's nice to have the drama, as long as the data is accurate and the numbers are accurate, and you're not kind of just creating dramatic pictures for the sake of it. Okay, so we have the real time, we have the picture in picture, and we had the thermal. Now, one last thing, palette. So this is the standard. Okay, what we call just the iron. It's not the iron. It's just the one that's from the image. So yeah, iron. This is the iron palette. That's the one that the image is taken into. A couple of other ones that we have. We have Arctic. So Arctic, you can use. I know some thermographers that just use Arctic. A bit cold, to be honest, as you can assume. But let me just play with it briefly. We'll keep that at 35. We'll take that up to 25. Yeah, and you can kind of see that. Right, if we were to play with this a bit, let's lift the bottom up. We can maybe shrink that down. If we take it down a bit, we might get a bit warmer in the bottom there. If we take the bottom end down a bit, okay, and then we can lift the top down a bit. So you can see how, in some situations, this might be more appropriate. Okay, it depends on the application. So that's the Arctic palette. And again, you can do fusion, you can do overlaying with that. Okay. Next one is grey. Now, grey, obviously, you see grey being used for things like security and CCTV and stuff, but it's got a good use. It's a bit bit boring really, but you can lift the top down. It's a nice bright white. You can lift the bottom up, shrink it up all the way up like that, and you can then fuse it. But you can kind of see how nothing really works as nicely when you play with some of these palettes. They have sometimes there'll be a picture where one particular palette is the best situation, and now and then you'll find a situation where grey really works. Grey is actually very good at if you have quite a lot of information and you're trying to really define the point. Grey can be used pretty well for that, but in this fuse it doesn't really work that well. We have lava. Let's go back to the main one, lava. So a lot of cameras actually, instead of iron, will have lava by default. It's another strong favorite. You see that it focuses most of these is focusing on just cold and hot colors. Arctic is more towards cold, lava's more towards the hot. But we could raise the bottom up, push that up, get that there, and you can get real nice kind of patterns with lava. Bring this, chase this top down. You can see that now we've got too much white, so we want to lift that back up just to get that. We want color. Too much white just means that you've just saturated it. There's nothing left. There's no more information to see. So let's lift that top end to 35, so we've got a lot of color there, and then we can just bring the top up and just watch that pattern form. And you can see that's where it starts, and as we expand on the span here, we can then just get it about right. You can see now we're having to have a lot more of the cable with this palette that we did with the iron. And if we then want to fuse that, we've actually got to come back from the top to bring that in. There we go. Let's get rid of that black. And just bring that down. So yeah, so could work. What else we've got? We've got rainbow and rainbow high contrast. Now, this one is actually, it's okay, but I kind of see it all the time. So I could bring that up, all the way down to there. Bring the top down. I can do the fusion. Yeah, that could work. It could work. High contrast is actually great, very useful when you need high contrast. So this thermal image, this image in particular, high contrast won't really gain much. Yeah, you can just see that there's just more drama with the contrast of the colors. Very good high contrast for things like collected breakers and things like that, where you really need to see an area and see which area of a number of items is really where the hot point gets to. You set it at high contrast, you have many more colors in the image, and then when you can, because you can see how many colors are in the spectrum here, and then you can really push down and find the source of the temperature where it gets to the red. Yeah, so you get a much higher contrast, and it obviously, what that means is obviously with certain temperatures in the scale, it offers those colors to certain points. Yeah, and there are more colors to play with here with the higher contrast one, which can look, it can work quite well. I've just seen this a lot, so it's not like the one I go to first of all. Sometimes though, with a report where it's all one palette, you do like to mix it up. Okay, now there's also these other things here called alarms. Okay, so that's palettes. There's these alarms. So above is where you set an alarm that any temperature at a point, so let's say that this temperature is 35, and I wanted to have a check, and if I wanted to make sure that this was not over 20 degrees, I'll set the alarm to 20 degrees, then anything that's over 20 degrees is going to be within that alarm. So, and we can adjust the span. So let's set the bottom to, I don't know what we've got there, 35, so let's set it to 25 degrees. Okay, so you can see how that this alarm, there's a span there, anything that's actually from the limit. So we've got the color here. We can change the color of the alarm. Okay, and the limit of the alarm, 25 degrees. Okay, so anything that is lower than that shouldn't be in the alarm. So let's set 15. And we can then just slide this. And then that can give us this alarm of color, wherever there is that temperature. So I can bring all of it into the image and then just have, so this is me just playing with the fusion, by the way. Here I'm playing with the fusion. If I get rid of that, I go to that. There we go. This might be a nice way for you to see it. Anything over 25 degrees is now that alarm color. I might want to say, okay, well, let's have anything that's over 30 degrees that color. Well, there we go. There's nothing at that temperature. Okay, because the ceiling of it is 28.7. So let's go to 25. That's there. Let's change that to blue. All right. Gives me options. That's a higher than, and I've done that with a few places where I'd have like equipment with a high surface temperature, and I'd set the surface temperature to 80 degrees or 70 degrees, and then I'd just blend the rest of the image out. So that like this, you can see this is an example where the palette options, gray is best working with alarms. It really is best working with your alarms in this case. So that's a high alarm. Let's say I want to go the other way. What if I need an alarm if anything is below something? Too cold, for example. Then it's the opposite. All right. So now the limit is 25. Anything below 25 is going to be blue, or red, or yellow, or whatever I want. So it's just swapping it around. This makes really the things that are over 25 degrees are white in this case. All right, don't use that one as much because things being too cold is not often on the radar for the work I would do, but you never know. Then you have the interval. So this is where you can say, okay, right, anything over 25. I already said 25 as the upper limit. And the lower limit is 22. So that means everything now that is coloured is between 22 and 25. So it's an interval. We've got humidity. So you go to humidity. You have to have a calculated limit of humidity. Okay, and then you can set it. So I don't have the values for this, but let's just assume that I have something to work with. Don't think it'll even work with it. No, let's just calculate, because there's nothing in the image that actually warrants the value that's been calculated by the camera. So there's no humidity in that one at all. But if there was, it would obviously, be starting to appear with a bit of a colour I chose. I often would use green for that. I don't know why I use green. I don't know. Insulation, and then we can have a custom alarm. So we can actually set up our own alarm. Okay, background colour. We can say, let's have the background as iron. And let's do a mode for an alarm for anything above. And if anything's above 24 degrees, let's have that this color, and then we'll realize that really iron looks crap with an alarm. So we can go, okay, well, what works well? Does Arctic work with an alarm? Does lava? This is where we realize that alarms really belong with grey. They just really work with that. Okay, so there's no real rules with regards to what you do with that. As long as you've got the key initial focus, you've got the angle, you've got the orientation, you've got the right reflective temperature, you've identified the emissivity, which you can adjust after if you've got everything else correct. You can then come back, and then with reporting is you can change all of the stuff to actually deliver the information to your client that you're trying to deliver. That's the key. Get the information to the client in a report. All right. And the best way to get used to that is just to practice. Just to keep practicing it. Where's my fusion? There's my fusion. Just practice. And it's the best way. Anything else? Yeah, we've got a zoom function. Yeah, so we can zoom in and zoom out. That's that. That's that. That's that. That's the picture-in-picture in the slider. Yeah, that's pretty much it. Okay. As I say, after you've done that, you can then add it to reporting. I'll probably do something else in reporting later. I don't really want to do anything on reporting now because I'll have to make loads of images first. But yeah, it's free to download from FLIR. You just kind of create a login to download it, and then obviously you'd need to have a FLIR camera to do that, because things like Fluke cameras and stuff, the images have a completely different protocol, so you need to use different software for that. But you can use, if you've got something like these little FLIR C3s or the FLIR 1 Pros, still works. You can still use the software for that as well. Okay, obviously these images are a bit better because they're a higher end camera, but you can still use those. Absolutely no problem. Alright, just wanted to kind of talk about that for a little bit. I'll see you on another thing soon.